Hi, in this video we will discuss Cherenkov radiation. Charged particle with high energy emits electromagnetic radiation in the visible region during its passage through a medium in which velocity of the particle is more than velocity of light. This radiation is called Cherenkov radiation. So this happens mostly in the nuclear reactors in which the fuel is cooled by water. It may be light water or heavy water. So I will give you a brief introduction why it is happening. You know, velocity of light is maximum in the vacuum. That you know it is approximately 3 into 10 to the power of 8 meter per second. If it is passing through a water, its velocity decreases by refractive index of water. Suppose refractive index of water is 4 by 3, then its velocity becomes c by 4 by 3. C is velocity of light. It means velocity of light is decreasing when it is passing through a denser medium. So in the same medium, in the water medium, the charged particle is moving. The velocity of charged particle in that medium exceeds velocity of light in the same medium. So this special type of radiation we are calling as a Cherenkov radiation, as it is discovered by Ceronkov, one of the great scientists. So why it is happening? So the main reason why it is happening, the gamma rays which are coming from the fission products are very high energy. This high energy gamma rays interacts with electrons of medium like water. So what happens? That electron will be ejected from the water molecule and that electron moves with high energy. This is high energy charged particle. So this charged particle, during its passage through the medium, it will undergo deceleration and emits the radiation. Okay. So how this electron is coming out from the molecule of the water, that can be explained through Compton effect, Compton scattering. Interaction of gamma rays with matter we will discuss. The gamma rays, the difference between other rays, especially X-rays, Bremsstrahlung and annihilation radiation. The gamma rays are high energetic electromagnetic radiation, and most important thing, it is coming from the nuclear transition. It means gamma rays are coming from the nucleus. Other electromagnetic radiations such as X-rays, Bremsstrahlung and annihilation radiation, which is outside the nucleus. Okay, X-rays, you know, there are two types, continuous X-ray and characteristic X-rays. Bremsstrahlung, that is due to charged particle decelerating through a medium. That time it emits the radiation. Another one is annihilation. What is annihilation? You know, electron and positron. Positron is the particle with charge positive, mass equal to mass of the electron. It is exactly antimatter for the electron. When the electron, which is a negatively charged particle, and positron, which is positively charged particle, both interact or combines, it emits, it disappears, I want to say. Electron and positron combines, they disappears and they become two gamma rays. That gamma rays are called annihilation radiation. Okay. Now we focus the interaction of gamma rays with the matter. Interaction of these X-rays, Bremsstrahlung and annihilation radiation, gamma rays with matter, more or less similar. We cannot distinguish how they are interacting. They interact almost similar fashion with the matter. Okay. Now we are focusing electromagnetic radiation with definite energy levels. So from which energy onwards, we are concentrating this interaction. That is from 0.01 mega electron volt to 100 mega electron volt. Remember this, 0.01 MeV up to 100 MeV. So this energy, electromagnetic waves, we are focusing their interaction with matter. Okay, gamma rays interaction with matter, there are many interactions, there are different types of the interactions. Out of them, I will mention in this video only 3 effects. The first one is photoelectric effect, second one is Compton effect, third one is pair production. These 3 are most important to discuss. Okay, gamma rays, apart from these 3, with high energy gamma ray can knock out one neutron from the nucleus, and gamma ray with sufficiently high energy can also make fission with heavy element. Remember this, gamma ray also can make fission with heavy elements. Okay, now this video most important is what I am focusing, interaction of gamma rays only. Okay, that one by one I will explain you now. So this is the equation for probability of photoelectric interaction equal to constant into z to the power of n divided by E cube. E is energy of gamma radiation, z is atomic number of absorbing medium. Photoelectric effect, now we will discuss. In the photoelectric effect, what happens? The gamma rays, when interacts with absorbing material, that gamma ray will be absorbed by electron in the innermost shell of an atom, and that electron will be ejected from the atom. Suppose energy of gamma ray is E and binding energy of electron with the atom is B. Then remaining energy E minus B, that will be kinetic energy of ejected electron. It means when gamma ray interacted with the absorbing material, it is removing innermost electron, and that electron is moving with high kinetic energy. That kinetic energy equal to the difference between energy of gamma ray and binding energy of that electron. You understood me? Then what happens? When electron ejected from the atom, vacancy created in the innermost shell of that atom. So that vacancy filled by electron transition from higher energy, that electron jumps to the lower energy. As a result of this, what happens? It emits characteristics X-rays. Okay, this characteristic X-rays also high energy. This X-rays also can remove an electron from the outer orbit of an atom. These secondary electrons are called Auger electrons. Auger means A-U-G-E-R. I am telling the spelling. You pronounce it how you want to pronounce. The secondary electrons are Auger electrons. Okay. Now we'll come back to the initial electron, which is ejected due to the gamma ray. That electron is moving with high kinetic energy. It is almost a beta particle, because high energetic electron, no, so it is almost like a beta particle that will pass through the medium, absorbing medium, same medium in which it is generated, and ultimately it will also undergo deceleration and it will emit the radiation. Finally it will come to the rest. Agree? So finally this electron also comes to rest. Secondary electrons also, they move with some velocity, and finally they will be decelerating and comes to the rest. And primary electrons, secondary electrons, both are coming to rest within the same medium. It means the gamma ray is completely absorbed in the medium. So gamma ray is absorbed by the medium with a process photoelectric effect. You understood? No? Then how this photoelectric effect depends with atomic number of absorbing medium. How this photoelectric effect changes with energy of gamma ray. It is like this. Probability of photoelectric effect is proportional to Z to the power of n divided by E cube. Z is atomic number of the atoms of the medium. E is energy of gamma ray photon. From the equation you can understand this probability is decreasing with energy of gamma ray. It means energy of gamma ray increases, photoelectric effect probability decreases. They are inversely proportional. And Z with atomic number, it is directly proportional. The photoelectric effect probability increases with increase in atomic number of absorbing material. I told Z to the power of n, no. N is a number. It varies from 3 to 5 depending on energy of gamma ray. Okay. So the photoelectric effect ultimately saying that it is absorbing the gamma ray, and most predominantly this photoelectric effect occurs with energy of gamma ray up to 1 mega electron volt. Remember this. Up to 1 mega electron volt energy of a gamma ray, this photoelectric effect occurs. Beyond 1 mega electron volt energy, what happens? Other interactions happens. In the photoelectric effect, the gamma ray expels the electron in the same direction if energy is high. It means gamma ray is coming like this. It will remove the electron from the atom and electron is moving in the same direction. Means this gamma ray is coming, absorbed by the electron in the atom, and this electron is moving in the same direction when the gamma ray energy is high. If gamma ray energy is less, how it will come out? Gamma ray is coming like this. Electron is absorbed. Electron absorbs the gamma ray and electron ejects 90 degrees. Electron will go along this direction. When gamma ray energy is low, electron expelled 90 degrees. If energy of the gamma ray between low and high, then electron may eject in between this and this, somewhere here, here it will expel. You understood, no? Now, after 1 mega electron volt of energy, what happens to photoelectric effect? After 1 mega electron volt energy of the gamma ray, the interaction changes to Compton interaction, Compton effect. In the Compton effect, the gamma ray photon undergo elastic collision with the electron of absorbing medium. Elastic collision means in which kinetic energy and momentum both conserves. That is elastic collision. So here the gamma ray is coming, interacting with the electrons of the medium, and it removes the electron from the atom. Actually, the energy of the gamma ray is so high such that the binding energy of electron with the atom is negligible. The gamma ray doesn't feel that electron is bounded to the atom because its energy is so high. So gamma ray is coming and elastic collision occurred, and gamma ray is going like this and electron is going like this. It means some part of energy of the gamma ray is given to the electron, then electron is moving as a free particle along this direction and gamma ray moving along this direction. The gamma ray initially coming like this and it turned like this, deflected like this. It is scattered. This is Compton scattering. It means in Compton scattering, the gamma ray is not completely absorbed. Understand? What happened? After interaction with electrons of medium, further it is moving with different energy. Here the gamma ray is coming with energy E and scattered with energy E prime. This E prime is less than E because some part of gamma energy is given to the electron. Then what happens after that? Gamma ray is coming like this, given some part of energy to the electron is moving like this, and gamma ray is moving with lower energy in another direction. Here also it can interact with electrons of another atoms of the same medium. Yes, it takes place continuously. It means gamma ray is coming like this and it's scattered. Here also one more electron is there, and here instead of moving like this, it may deflect like this. It is continuously undergoing scattering. For every scattering, the energy of gamma ray is decreasing. Understand? So, gamma ray energy is decreasing. It may come below or equal to 1 mega electron volt. Then the interaction shift back to the photoelectric effect. You know, the photoelectric effect probability is inversely proportional to energy of gamma ray. So energy is decreasing, probability increases. So ultimately, after Compton scatterings, the gamma ray energy entering into photoelectric effect, and finally it will be absorbed in the medium with photoelectric effect. So this is called Compton effect. In single sentence Compton effect, you can say the gamma ray interacts with electrons of the medium, undergo elastic collision, and it will deflect in different direction with energy less than the original gamma ray, and electrons move because of some part of energy of gamma ray given to that electron. This is Compton effect or Compton scattering. Okay. Here what happens? How much energy lost by the gamma ray? How much energy of the scattered gamma ray? The fraction of scattered gamma ray energy and the fraction of energy lost by the gamma ray. We have some equations. That equation you can see. See here, E prime is energy of scattered gamma ray equal to 0.51 divided by 1 minus cos theta plus 0.51 divided by E. Okay, here it's supposed to be E, energy of the primary gamma ray. It's supposed to be E. Okay, this is actually what happening. Incident gamma ray is coming, it is scattered. Incident energy is E, scattered gamma ray is E prime. This is electron. This theta is scattering angle. In the formula, cos theta is there, no? Theta. This theta is scattering angle. If it is going straight, deviation is very less. Cos 0 is 1, no? So cos theta equal to 1. So approximately the scattered gamma ray energy is same as incident gamma ray. There is no loss of gamma ray energy. If theta is equal to 90 degrees, what happens? The E prime, the energy of scattered gamma ray equal to 0.51 into E divided by E plus 0.51. It is less than 0.51 MeV. If it is undergoing scattering by 90 degrees angle, the energy lost by the gamma ray is higher. Okay. The probability of Compton interaction equal to constant into Z by E. So this is also inversely proportional to energy of gamma ray. Compton scattering is directly proportional to atomic number of absorbing medium and inversely proportional to energy of gamma ray photon. So the probability you can remember like this. The probability of Compton scattering is proportional to Z divided by E. Z is atomic number, E is energy of the photon. Okay. Now we will go further. Another interaction we will discuss, that is pair production. Pair production means the gamma ray with sufficient high energy going near to the nucleus under the high electric field, the gamma ray photon becomes two particles, that is electron and positron pair. Remember, the energy of gamma ray is high enough to produce a pair production. What is the minimum energy of gamma ray? It is 1.02 mega electron volt. Why it is so? 1.02 equal to 0.51 plus 0.51. So what is the special about 0.51 MeV? 0.51 MeV is rest mass energy of electron. As per the Einstein relation, the electron mass is there, no, into c square. The energy equal to 0.51 MeV. To form a electron and positron pair, the gamma ray photon energy should and must be more than 1.02 mega electron volt. This pair of electron and positrons produce, and they mostly moves along the direction of incident gamma ray. So gamma energy is converting into mass, energy converting into mass. This is one of the best example, pair production. Okay, if energy of gamma ray is much higher than 1.02, suppose, then what happens to remaining energy? Remaining energy will be given mostly to the electron and positron kinetic energy. The most of the higher energy, more than 1.02, the remaining energy mostly given to the kinetic energy of electron and positron. Some fraction of energy will be given to the nucleus. Okay, so gamma photon is coming like this, and with the nucleus very near it is coming, and it disappears into two particles, that is positron and electron, and they move almost same direction to conserve the momentum. Okay, so this is the pair production. In the pair production, what is the beauty is the gamma ray is completely absorbed. The gamma ray disappeared. The primary gamma ray is completely disappeared and it becomes into electron and positron. In the photoelectric effect, gamma ray is completely absorbed. In pair production also, gamma ray is completely absorbed. But only in Compton scattering, the high energy photon or gamma ray, high energy gamma ray is coming and it is scattering. And further it will scatter, finally it will undergo photoelectric effect and it will be absorbed. The most important thing you have to remember is in photoelectric effect and pair production, primary gamma is absorbed completely in the medium. You understood? So probability of pair production equal to constant into z square into E minus 1.02. Okay, if energy increases, pair production increases. If atomic number increases, pair production increases. This is different from photoelectric effect and Compton scattering. Okay. Probability of pair production is proportional to z square into E minus 1.02. Remember this. The probability of pair production is proportional to z square into, in the bracket, E minus 1.02. E is energy of gamma ray. Z is atomic number of absorbing material. Why it is 1.02, E minus 1.02 I am writing? Because 1.02 is minimum energy of gamma ray to undergo pair production. So energy, if it is more than 1.02, the probability is high. Only for pair production, this probability increases with energy. Higher the energy of the gamma ray, higher the pair production. Whereas in Compton scattering, the probability of Compton scattering is proportional to Z by E, and probability of photoelectric effect also, that is Z square, Z to the power of n by E cube. So photoelectric effect and Compton scattering both will decrease, their probability decreases with increasing energy of gamma ray. But only in pair production, if gamma ray energy increases, pair production probability also increases. I hope you understood perfectly these most important interactions. One is photoelectric effect, Compton scattering, and pair production. Thank you for watching this video. Like this video, share this video, and subscribe my channel. Thank you.